Hello, Chem 20s. Our review lesson today is on ionization. An atom has the greatest stability when its highest energy level has a filled stable octet. Ionization is an atom's ability to lose or gain electrons in order to gain a more stable electron configuration. This would be similar to trying to be more like the noble gases, a full outer energy level. Ions have a charge because the number of positive protons and negative electrons are no longer balanced. Reminder, in an atom, protons and electrons add up to have a net charge of 0. They cancel out. In an ion, we're going to have either more electrons or less electrons than the number of protons. Therefore, we're going to come with a positive or a negative charge. For instance, let's look at magnesium. If you take a look on your periodic table, magnesium is element number 12. So I'm just going to get myself a pen here. We'll do red, we'll do lower line here. This will be perfect. So magnesium is element number 12. Therefore, it's going to have 12 protons. If it's got 12 protons, magnesium atom is going to have 12 electrons, 2 electrons in the first shell, 8 electrons in the second shell, 2 more electrons in the third shell to add to 12 electrons. Since it has a mass number of 24.31, 12 plus what equals 24? This is going to be 12 neutrons. Now, when we're comparing atoms to ions, and this is going to be magnesium ion, you will notice that inside the nucleus, nothing changes. We will still have 12 protons. We will still have 12 neutrons. If you think about it, I have an atom here and something else is going to come close to it. Which part of an atom is going to react the most, which is going to have an interaction with a neighboring other atom or compound? It's the outer electrons that are going to come in contact first. Inside the nucleus, it's going to be safe. So the protons and the neutrons will not change. It's only those valence electrons that's going to have an interaction. So when I look at this, 12 protons, 12 neutrons, the same in an ion compared to an atom. We will still have 2 electrons in the first shell, 8 electrons in the second shell. What you have to ask yourself is, would my atom rather donate 2 electrons, or would it to get to a full shell, or would it rather gain 6 electrons to get to a full shell? And the trick is, it's always going to do the easiest process. So it is much easier to lose 2 electrons than it is to gain 6 new electrons. So it's going to give up 2. So now when I add this up, I have 10 negative electrons. I have 12 positive protons. So we have 2 more positive protons in magnesium than we have negative electrons. That is why magnesium, if you check your data booklet, has a 2 positive charge. Charges or ions do not come out of thin air. It makes sense on when they donate or gain electrons, where they get their charges from. So we use a term, anytime a metal loses electrons, and all metals lose electrons, they are called cations. So sodium, Na positive, is a cation. Aluminum, Al3 positive, is an cation as well. If you gain electrons, and nonmetals are the substances that gain electrons, you become negatively charged. Therefore, we call you an anion. Sulfur has a 2- charge, so we call it sulfide. It's a sulfide anion. Bromine gets a negative charge. That makes it bromide. It gets a bromide anion. Again, if you're negatively charged, not only are you a negative ion, you also have an IDE ending. So let's try a few of these. So fluorine, if I look it up, is element number 9. So it has 9 protons, which means it's going to have 9 electrons in an atom. Protons and electrons equal each other in an atom. So 2 electrons in the first shell, 7 electrons in the second shell. The mass number of fluorine is 19. So 9 plus what is 19? That's going to be 10 neutrons. Well, when I change from an atom to an ion, I want to get to a full outer energy level. We want to get a noble gas configuration. So everything inside the nucleus stays the same. So I still have 9 protons and 10 neutrons. We're still in the first shell going to have 2 electrons. Would fluorine rather gain 1 electron or lose 7? It would rather gain 1, so it's going to be 8 electrons now. It now has a total of 10 negative electrons compared to 9 positive protons. It has 1 extra negative electron. That's where the 1 minus charge comes from. Because this is a nonmetal or an anion, it gets an IDE ending. Fluorine atom is now fluoride ion. Can you please pause the video and try the next 2 examples for me, please? So potassium atom is element number 19. So that means 19 protons. 2 electrons in the first shell, 8 electrons in the second shell, 8 electrons in the third shell, and 1 electron in the outer valence electrons. Since potassium is 39.10, 19 plus what equals 39? That's going to be 20 neutrons. Again, when I go from an atom to an ion, everything inside the nucleus stays the same. So it's still 19 protons, 20 neutrons, 2, 8, 8, and we have to ask ourselves, is it easier to gain 7 or lose 1? It's easier to lose 1. So when I add up the negative electrons, we now have 8, 16, 18 negative, 19 positive. Therefore, we have 1 extra positive. If I check my table, potassium has a 1 positive charge. Therefore, potassium atom has turned into potassium ion. For nitrogen, nitrogen is element number 7. So that is 7 protons, 2 electrons in the first shell, 5 electrons in the second shell. It has to add up to 14 mass number. So 7 plus what is 14? That's going to be 7 neutrons. Because this is an atom, inside the nucleus will be the same for an ion. So this is still going to be 7 protons, 7 neutrons, 2 electrons. Now, is it easier to gain 3 or to lose 5? It's easier to gain 3, so this is going to be 8 electrons. Again, this has 10 negative compared to 7 positive. So this is actually called N, or you'll see it, it's underneath my video. So I'm going to do, this is N. So because it has 3 more negative electrons, we're going to say nitrogen has a 3 minus charge. And we're going to call this nitride ion because when it's a nonmetal, it gets an IDE ending for an anion. So we're going to now go to the next page. Okay, another chart. Pause the video. Instead of drawing pictures this time, let's see if you can fill these in by just looking at the work. So we're going to find lithium. Lithium is element 3 on your periodic table. Therefore, it's going to have 3 protons. Since it has a mass number of 7, rounded to a 7, 3 plus 4 is 7, so 4 neutrons. Since lithium has a 1 positive charge, it's going to have 1 extra proton. So if it has 3 protons, it's going to have only 2 electrons because 3 positive plus 2 negative gives me an extra positive. That's where lithium gets its positive charge from. Okay, now when I see oxide ion, I know I'm looking at something that is charged. So in symbols, this is going to be O. And if I check my data booklet, the charge on oxygen is 2 negative. Now we've got to prove it to ourselves. So oxygen is element number 8. So that's going to be 18 protons. Oxygen also has a mass number of 16. So 8 plus 8 neutrons gets me 16. And if I have a charge of oxygen ion of -2, that means I'm going to have 2 extra electrons compared to protons. So instead of 8 protons, I'm going to have 10 electrons. 2 extra negatives over the positives gets me my 2 minus charge. Pause the video, make sure you're doing the other 3 yourselves. So phosphide ion is actually phosphorus. The charge on it is 3 minus. Phosphorus is element number 15, so that is 15 protons. The mass number on phosphorus is 31, so 15 plus 16 neutrons is 31. Again, if I want a charge of 3 negative, I need 3 more electrons than protons, so I need to have 18 electrons. 18 negative compared to 15 positive gets me my extra 3 electrons. Calcium ion, well, calcium is element number 20, so that's 20 protons. It has a mass number of 40.08, so it rounds to 40. 20 plus 20 is 40. And then if I want to have a 2 positive charge, I need 2 more protons than electrons, so this one's going to be 18 electrons. Last but not least, find iron. Now, iron has more than one charge, so this is iron 3 plus. So iron is element number 26, so that's going to be 26 protons. The mass number is 55.85, so that's 56. So 26 plus 30 is 56. And then if I want a 3 positive charge, I need 3 more protons than I have electrons. So I should only have 23 negative electrons. So I have 26 protons. That gets me the 3 positive charge. Let's look at an example of table salt. When neutral atoms collide, an electron is transferred from one atom to the other, and both atoms becomes particles called ions which have an electrical charge. One becomes a cation, one becomes an anion. So going through this quickly, let's look at sodium atom. Quickly draw the diagrams for the atoms and the ions, please. So sodium atom is element number 11, so that's 11 protons. That means 2, 8, 1, because these are atoms, so the number of electrons and protons equal each other. Again, we have to add to 23, so that's going to be 12 neutrons. Chlorine, on the other hand, for an atom is element number 17, so that's 17 protons. 2, 8, 7. And again, 35.45 adds to 35, so 17 plus 18 neutrons gets me 35. Well, in this example, when we look, when I go to change the atom into the ion, I know that everything inside the nucleus stays the same. So inside the nucleus for sodium or inside the nucleus for chlorine, those values aren't going to change. However, the electrons are. Would my atom rather gain 7 electrons in the outer shell to be full or lose 1? Well, it would rather lose 1. And would my chlorine atom rather gain 1 electron or lose 7? Well, it would rather gain 1. Well, the question is, where is it gaining or losing these from? Well, I can show that in my picture of my example for table salt. Since sodium would rather lose 1 electron, and chlorine would rather gain 1 electron, this is where in an ionic compound we have a transfer of electrons. Since sodium gave away an electron, it has now 11 protons compared to 10 negative electrons. It has an extra proton. It has a 1 positive charge. And I'm going to make that a little bit bigger. So it is a cation because it has a positive charge. And when I look at chlorine, chlorine gained an extra electron, so it now has 10, 18 negative compared to 17 positive. So it now has an extra 1 negative charge. So that's an anion. And because it's an anion, not only is it negative, but it gets an IDE ending. So sodium atom becomes sodium ion, where chlorine atom becomes now chloride ion. This is full energy levels. This is why table salt is so inert. You eat it, you can process it, things like that. Well, let's look at multivalent ions. On your periodic table, you have some ions, some electrons, some elements that have more than 1 positive charge. For instance, iron has, if you look, iron 3 or iron 2 ion. Vanadium is vanadium 5 or vanadium 4 ion. Titanium is titanium 4 or titanium 3 ion. Just to get you looking, can you find the following atoms and tell me what are the possible ions for these following atoms? So chromium, if I look, can be either chromium 3 positive or it can be chromium 2 positive. Copper, if you look, can either be 2 positive or copper can be 1 positive. And gold, if you look, can either be 3 positive or gold can be 1 positive. Polyatomic ions are those ions where you have multiple atoms bonded together to make kind of a molecule, but this molecule comes with a charge. That charge goes with the whole molecule. This is the table found above the periodic table. So something like carbonate ion, both carbon and oxygen bonded together, CO3 has a -2 charge for the whole thing. We call that the carbonate ion. OH together has a -1 charge. That's called the hydroxide ion. And NH4, so nitrogen bonded to 4 hydrogens together, has a 1 positive charge. That's called the ammonium ion. Using your table of polyatomic ions, what are the charges for sulfate ion? So that's going to be SO4, the charge is 2 minus. Phosphate ion, PO4, the charge is 3 minus. Acetate ion is CH3COO, 1 minus charge for this whole polyatomic ion. And the nitrite ion is NO2 with a 1 minus charge. Using all this information that we have gained over the last few slides, let's start the next worksheet early, and I'm going to do the first 3 with you. So each of these 3 are very, very different, and these will hit all the different criteria you have on this next worksheet. So on your periodic table, find neon atom. Since it's an atom, we know that the symbol is Ne. We don't need a charge because it's an atom. The number of protons will equal the mass numbers. So, sorry, the atomic numbers. So neon is element number 10, so it'll have 10 protons. Since it has 10 protons, it will also have 10 electrons because it is an atom. And protons and electrons cancel out. Since it's already got a full outer shell and it's an atom, so it has no charge, the number of electrons lost or gained is always going to be 0, which means its charge is going to be 0. If you are an atom, you do not have a charge. If you are an atom, you do not gain or lose electrons because you are already perfectly balanced and atoms don't do that. So the first one, neon atom. Anytime you have an atom, it's going to be protons, same number, 0, 0. So 10, 10, 0, 0, 5, 5, 0, 0. Atoms have the same number of protons and electrons, no charge. It's an atom. Now, lithium ion is different. So I'm going to put it here in symbols, Li, but remember, it's an ion. So it's going to have a charge. So my data booklet tells me it is a 1 positive charge. Lithium is element number 3, so it's going to have 3 protons. If it's got 3 protons, the only way it's going to have a 1 positive charge is if it has 1 extra proton compared to electron. So if it's got a positive 1 charge, that means it has 1 more proton than electron. So lithium ion is only going to have 2 negative electrons. It's going to have an extra positive proton because it's got a positive 1 charge. The only way this can happen is if the atom gives away or loses 1 electron. Remember, this is the loss or gain of electrons from the outer shell. So it gives away 1 electron. That means it has 1 extra proton. That means it's going to have a net charge of 1 positive. So we have done an example of an atom and an example of an ion. The numbers are going to be different in an ion because we are going to be gaining or losing electrons. Let's try one other one. So we have a substance with 18 electrons, 18 negatives. We know it has a net charge of 2 minus, which means it has 2 more negative electrons than positive protons. So it's going to have 16 positive protons. Element number 16 on your periodic table is sulfur. So we do not, in its ion form, call it sulfur. We call it sulfide because it is a non-metal. So it gets an IDE ending. And we will write the symbols as S2 minus. Because it's an ion, it has a charge. I know it has a charge because the number of protons and electrons are not equal to one another. How did my 16 positive protons become 18 negative electrons? It gained 2 electrons. That's where it got its 2 negative charge from. It gained 2 electrons. The reason I wanted to do all 3 of these examples off your worksheet is I wanted you to see an example of an atom. All atoms are very, very similar. The number of protons and electrons are equal, and the number of electrons gained or lost and the net charge is going to be 0 because they are atoms. Ions are going to be different. I wanted you to do a metal ion. I wanted you to do a non-metal ion. Really, the biggest difference between a metal and a non-metal ion is in a non-metal ion, you have to change the ending to IDE. So instead of sulfur ion, it's actually sulfide ion. Good luck on the following worksheets.